Okay, so in the last week, we have the cost-based optimization methods for optimizing the queries, right? So the main idea is to apply the nodes we introduced before until this estimated cost is minimum. And we have two approaches for the optimization. The first one is called top-down, and the second one is called bottom-up, right? And we also introduce the strategies we can use for searching, right? And we can have this branch and bound, the hill climbing, as well as dynamic programming as the algorithm for searching, right? So in this week, we will introduce detailed information how to do this cost-based optimizations, as well as how to use dynamic programming for searching the optimal partial plans until we achieve the final result. So we can use an example to show you how we use this algorithm for optimizing the queries. Let's assume we have a query. We have R1 to Rn as the relations or the tables, and we want to calculate the joins among them. So, given this query like this, we can calculate the join among all these relations. We can have different way to do this kind of queries, right? In this page, we show you with the example of the execution plans or the logical plans. So, given the R1 to Rn this relation, we want to calculate the joins among them. We can have different ways. This is the example. We can do the joins according to the logical plan or logical tree as shown here. Given relation R1 and R3, we can calculate the join between them first, and also calculate the join between R4 and R2 first. And based on this intermediate result, we can further calculate the joins between these two intermediate relation or results and to calculate the final result. So this is one way to calculate the joins, right? You can see, in this logical plan, this join tree is balanced. We have two inputs here, and given the intermediate results, two results, we can further calculate the final result. So this is one plan or one join tree we can use for execution this kinds of queries. So the plan we have here is actually also a join tree, right? We can name this tree as a join tree as shown here, and we can also name this tree as a logical tree or the logical plan for executing this query, right? So this plan will be a join tree. Also, we can mention a partial plan for executing this query as a subtree of such a join tree. Now we can name this kind of subtree involving the join between R3 and R1 as a partial plan for executing this query, similar for this partial tree, right? It will also be a partial plan for executing this query as well. So, this is the join tree we have here, and we also name it as a plan. Besides this, we can also have different formats of the join trees, right? Depending on how we organize this kinds of relations, as well as how we put these join operators among them. This is one example. Another example we can have is like this. We have a network branch to be very deep. Let's assume we have multiple relations R1 to R5. And we can organize a join tree to be like this. Given R1 and R3, we can calculate the join between them first, and then we can further join the intermediate result with R5, and then we can further join with R2 and with R4 to get the final result. This will be another example for the join tree, right? This is also valid because according to the nodes we showed before, the orders we do the join doesn't matter, right? You will achieve the same result. However, we will have different formats of the join trees if we organize this kind of relations as well operate in different ways. So this is another example. Besides this, we can have another example, right? We are still doing the joins among these relations. However, here we do the joins between R1 and R5 first, and then join the intermediate result with R3, and at the same time we can join R2 with R4, right, to get the intermediate result. Finally, we can join them all together with the final operator at the top. So this is another format of the join trees. So you can see, given the same query inputs, we can have different logical plans for executing the queries. The question will be which one will be the best, will be the optimal, and it will be the target for this part, right, for the query optimizations. We want to find the best or the optimal join trees for executing this query like this. So this is the main target for this section, and we will introduce how to achieve this optimal logical plans for the query inputs.